And welcome to the fourth and final part of our presentation on the third chapter, microwave active components. Myself Sanjit Kumar Singh, lecturer in electronics and telecommunication department at Praveen Patil College of Diploma Engineering and Technology. So in this presentation we'll see the other semiconductor diode, that is Esaki diode or tunnel diode, and we'll see its VI characteristics, equivalent circuit and applications. Learning outcome, of course, is to describe with relevant sketch the operation of the given microwave component, and course outcome of third chapter is to maintain active microwave components and devices. So tunnel diode is another negative resistance diode, as it creates a narrow range of negative resistance. This is due to the quantum mechanical effect, that is the tunneling when forward biased. Tunnel diodes are used to produce low power microwave oscillations or amplifications as well. Tunnel diode is also known as Esaki diode, named after the scientist Leo Esaki, who was working for the Sony company in 1957, and for his work on this effect he got a Nobel Prize in the year 1973. It is so tunnel diode is a type of semiconductor diode that has effectively negative resistance or the dynamic resistance due to the quantum mechanical effect called tunneling. Tunnel diodes have a very heavily doped p-n junction that is about 10 nanometer wide. So down here we see the equivalent circuit of a typical tunnel diode consisting of a series resistance of 6 ohm, then the parallel resistance, negative resistance of 75 minus 75 ohm, capacitance of 0.6 picofarad, and series inductance of 0.1 nanohenry. For the construction, we see the construction of a tunnel diode. It consists of a very tiny dot made of about 50 micrometer in diameter of tin, and is soldered on it is soldered or alloyed to a heavily doped pellet of n-type germanium or gallium arsenide or gallium antimonide. The pellet is then soldered to a cover pedestal. Down the hashed portion is the pedestal over which it is placed, which is used for heat dissipation. The pedestal is used for heat dissipation, which forms the anode contact. So the pedestal is also forming anode contact. The cathode contact is also covered up, we are seeing, being connected to a tin dot via a mesh screen is to reduce inductance. The mesh screen is to have lesser inductance, as the leads provides high inductance at high frequencies. The diode has a ceramic body, we see, and is hermetically sealed with a lid on the top of cathode. So that is the structure of the tunnel diode. Then how tunneling is taking place, and what is tunneling effect? The flow of electrons from the n side to p side after crossing the potential barrier or depletion region is known as tunneling. With the decrement in the depletion region of the diode, charges can move across the potential barrier. For this crossing, there is no need of any kind of energy for charges. This process is known as tunneling, and due to this fact, the diode is called tunnel diode. So in the diagram we see the barrier potential and is when the electron is overcoming this barrier potential and moving to the p type from n type, it is forming a tunneling. So for the characteristics, VI characteristics, question has been asked in MSBT for 4 marks. So when the reverse bias is applied, the Fermi level of p side becomes higher than the Fermi level of n side. Hence, the tunneling of electrons from the valence band of p side to the conduction band of n side takes place. With the increments of the reverse bias, the tunnel current also increases. So when forward bias is applied, the Fermi level of n side becomes higher than the Fermi level of p side. Thus, the tunneling of the electrons from the n side to p side takes place. The amount of the tunnel current is very larger than the normal junction current. When the forward bias is increased, the tunnel current is increased up to certain limit. When the band is of n side is the same as the Fermi level in p side, the tunnel current is maximum. With the further increment in the forward bias, the tunnel current decreases and we get the desired negative conduction region. When the forward bias is raised further, normal p-n junction current is obtained, which is exponentially proportional to the applied voltage. So we are seeing the VI characteristics of the tunnel diode. So there is a tunneling current in the reverse direction as well as in the forward direction that increases to a certain level to a peak point. Say this is of the order 2 milliampere from low point, a valley point current of 0.2 milliampere. So from 0.2 milliampere, the current is increasing to 2 milliampere to the peak point, and thereafter there is a fall in the current as slight increase in forward biased. So this dynamic resistance characteristic is of very much importance, and again by increasing the voltage further, DC bias voltage further, we can increase the conventional diode current. So this process can be repeated and can be used for microwave oscillation production or for generation of microwave signal. So the given VI characteristic is of that of the germanium. So here is one of the application of the tunnel diode as an oscillator. The diagram we see, tunnel diode can make a very stable oscillator circuit when they are coupled to a tuned circuit or cavity. So in the diagram we see a tunnel diode that is coupled with the loosely coupled with a cavity with the help of using a short antenna feed probe placed in the cavity off center. This increases the stability of oscillation and achieve output power over wider bandwidth, that is few hundred microwatts. So the diagram, adjacent diagram, explains its working as an oscillator. It can be used as an amplifier as well. So as an oscillator it can be used for 100 gigahertz, and since the time taken for the device to cross the tiny dot from anode to cathode is very less, so it can be used as a high frequency switch. It can be used as mixture, and due to its resistance or resilient to the effects of magnetic field and high temperature and radioactivity. It can be used in military equipment and in nuclear magnetic resource machines also, and is most importantly used in satellite communication equipment. So what are the advantages of tunnel diode? Its advantage is its longevity, that is longer life, stability, and faster operation, high speed switching operation can be done, and hence can be used in flip-flops and gates. It creates less noise during operation, and it uses less power and less current in milli and micro ampere current is used. Tunnel diode disadvantages are its input and output terminals are not separated from each other. So these diodes are constructed in limited numbers. So here is a summary of what we learned in this presentation. We saw the symbol of the tunnel diode. Then we saw the equivalent circuit consisting of a series resistance and tank circuit formed of the negative resistance and capacitance, and in series with the inductance. Then we saw the construction diagram consisting of a tiny dot of 50 micrometer in diameter, and there is a messy screen connector connecting the anode to cathode, and anode and cathode are made of cover, and the anode structure is also acting as a heat sink for dissipating the heat generated. Then we saw the VI characteristics. The VI characteristic is uh, useful range is in the negative resistance region, that is between peak point A and the valley point B. So this cycle can be repeated and sustained oscillations can be produced, or even amplification purpose can make use of tunnel diode. So thank you.